Hi children, and welcome to the lesson number 1 of chapter 6, area of triangles. In this lesson, we are going to cover the topic base and height of a triangle, because in order to find out the area of a triangle, we need to know the base and height of a triangle. So let's consider a triangle ABC. Now in this triangle, how we are going to find the base and height of a triangle. So let's start. So first of all, it is clear that we can use any side to find out the base and height of a triangle. So let's consider that in triangle ABC, if BC is a base, then AP is the height of the triangle. Why? Because this line, which is called AP, is making a perpendicular to vertex A from base BC. Similarly, when AC is the base, BQ is the height, because BQ is the line that is making a perpendicular to vertex B from AC. Similarly, when AB is the base, then RC or CR is a height, because this is the line that is making a perpendicular to vertex C. So in this way, we have found out the base and height of a triangle. In question 2, we have a triangle EFG and we have to find the height of a triangle EFG. So the first scenario is that in which FG is the base, so EH is the height. And in order to find the height, we have extended the triangle from point G to the point where we are able to make the straight or perpendicular line till vertex E. So in that way, we have find the height EH when the base is FG. Now in second scenario, the base is EF and we can easily draw a straight line from this base to the vertex G, and let's say we have called it point J, so we have a height J, G or GJ for the base EF. Now in the last scenario, GE is the base, and in order to find out the height, we have extended that base to the point where we are able to make the straight line till vertex F, or the perpendicular lines that we are able to find out the height. So we have extended it to the point and call it K. Now FK is the height in the case when GE is the base. In that way, we have find out the height of triangle EFG. Now in question 3, we have to name the height for the given base for each triangle. In part A, we have a triangle GFE and the base is FE, so the height is GF, because this is the straight line from point F to G, so this is the height. Now in part B, when ST is the base, we have drawn a perpendicular line from an arbitrary point which we called U to the vertex R. So RU is the height of the triangle. Now when AB is the base, CD is the height, and in order to find out that height, we have extended the base till point D, so that we are able to draw a straight line till vertex C. So CD is the height of the triangle in case AB is the base. Now in question 4, for each of the following triangle, we have to name the base for the given height. So when BC is the height, the base is AB, because if BC is a height, so this is the straight line and the base should be AB, from where this line is drawn and making a perpendicular. Now in part B, we have EG is the height, which is from there. So DF is the base basically, because if DF is the base, then only when we are going to draw an arbitrary line from point G to vertex E in order to find out the height. So DF is the base. Now when JK, in the last part, when the JK is the height, then ML is the base, because in order to find out the height JK, we have extended this base to find out the height. So ML is the base of this particular triangle. In question 5, there are three triangles OMN, LMN, and PMN. They share the same base, which is MN. The triangle have different heights. So we have to identify which height belongs to which triangle. In part A, which triangle has LR as its height? LR is the height of the triangle LMN, because LMN is the triangle with the base MN is making a perpendicular line RL, so this is the height of the triangle LMN. Now in part B, which triangle has QR as its height? If we look at QR, we can simply guess that this is for OMN. This is the for the triangle OMN. And for C part, which triangle has PS as its height? As we know that PMN is the triangle that we have extended in order to find out the height PS. So this is the height of the triangle PMN. In question 6, we have ACDF is a rectangle. So in triangle BCD, when CD is the base, then BC is the height. If we look at this triangle BCD, if CD is the base, then it's very easy because BC is the straight line from C to B. So this is the height of our triangle. Now in part B, in triangle BDF, when DF is the base, the height, what are the possible heights of the triangle? The first possible height is the CD, because if in BDF triangle, if we draw a line from between the D and B, so it is a straight line which is exactly equivalent to CD and also equivalent to AF. So this is the height of the possible heights of the triangle. Now in part C, CD is the height of a triangle. C and D is the height of triangle. Name the two possible triangles. See, if CD is the height, then ACD can be a triangle, and also BCD can be a triangle, because in both these triangle, the base BCD and ACD. So base can be different, but the height is same for both of these triangles. So these are the possible triangles for this particular height. In question 7, we have to name the base for each given height of the triangle. So when the height is CX, then the base is AB. Why? Because it is the base AB from where the line CX is making a perpendicular. So if CX is the height, then the base is AB. Similarly, when the height is AY, then the base is CB, because from this base, the AY line is making a perpendicular, so the base is CB. And similarly, when the height is BZ, the base is AC, because from this base, the line BZ is making a perpendicular to vertex P. Now in part B, when the height is RD, the base is EF, because this is the base from where the line RD is making a perpendicular. So, and in the next case, when the height is QE, the base is FQ, because if the height is QE, then this is the extended base FQ, which is making possible to make a line and measure the height. Now when the height is PF, then the base is DE, Why? Because DE is the base which we from where we have extended the line, and then draw a line from point P to vertex F. So if PF is the height, then DE is the base of the triangle. Now, in question number 8, you have to perform the activity by using the set square, and with the help of the set square you can find out the base and height of the triangles. So perform this activity with the help of set square. Now we have reached the last part of the video, which are practice questions. So the question number 1 is, name the height for the given base in each triangle. Now, when the base is YZ, we need to find out the height. So if the base is YZ, then the height is simply XJ, because this is the line that is making a perpendicular from the base YZ. So this is the height of this triangle. For part B, when the base is PQ, then what is the height of the triangle? In order to find out the height of the triangle, we have extended the base PQ to the point E and then draw a line from E to vertex R. So RE is our height of this triangle. Now in question 2, we have to find out the base of a triangle ABC when AH is the height. If AH is the height, we can clearly see that the base we have extended, which is BC, in order to find out this height, which is AS. So BC is the base of this particular triangle. Now in question 3, there are triangles PQR, SUR and TRV, and they all have the same height. As you can see from the dotted lines, the blue dotted lines, they all have the same height. XT, SW and PQ, they all have same height. PQR, SUR and TRV, they all have the same height. Now we have to answer the question that do have the same base. The answer is no, because if you look at the colored lines which I have drawn in order to highlight the base of each triangle. So for the first triangle PQR, the base is represented by RQ, which is the first line, which is the tallest line. And for the next triangle SUR, the base is from R to U, which is smaller than the previous one. And for the last triangle TRV, the base is start from R to V, which is the smallest among the three. So as you can see, the base for each triangle is of different length, so we cannot say that they have the same base. Now in question 4, we have a figure BCEG, and this is a square. Now we have to identify the triangle that have the same height as triangle ADF. If we look at the heights, so we can find out that first ABG is the triangle which is has the same height as the triangle ADF. Because if we, in order to find out the height of the triangle ADF, we will draw a line from the middle of the base AD to the point F, and it is equivalent to BG. So the triangle ABG has the same height. So similarly AGF is also a triangle which has the same height, because again we will extend the base DF in that case and draw a line which is again equivalent to BG, so it has the same height. Now for DEF is also a triangle which has the same height, because again, in order to find out the height of this triangle, we will extend it and draw a line from D to the extension to the point D, so which is exactly the same as the height of CE. So this is also a triangle which has the same height as of ADF. Now the last one is the CDE. Again, the height is CE, so which is similar to the height of the triangle ADF. So these are the four triangle which has the same height as that of a triangle ADF.